Yeah. So please just quickly like unmute yourself to speak, or you just drop a comment of where you stopped last week. Please just need a few replies so I would know exactly where to take it up from. Nobody's saying anything. Can someone just let one person just say where you stopped? Then you have the like privilege of us starting from where you stopped. Okay, data types. Okay, okay. So that means you already discussed variables. So data types. Okay. So what data type were you taught? Like which of them or how many were you taught? Okay. So before I even go further, please always feel free to talk. You get so just you can even while I'm talking, you can raise your hand, you can drop a message, or you can even unmute yourself and just like say like you want to ask something, right? So that nobody wants to say anything. Anybody can just say anything and like out. Yeah. Chiamaka, you can say something.
Okay, good evening. Can you hear me?
Yeah, I can hear you. Good evening.
Okay, so last class we learned about the solidity data types. We talked about the value types and reference types. So
Okay.
he explained signed and unsigned integers, Boolean, address, enums, bytes. Then under reference types, we talked about arrays. We talked about different types of arrays. Um, then we also talked about structs and mapping. I think we stopped at mapping. I didn't really understand the mapping, but yeah, that's where we stopped.
Okay. Thank you very much for that. Amadi Ogechi, please go ahead.
Okay, good evening.
Yeah, good
About that,
evening.
that class was kind of it was supposed to be cancelled and then it was rescheduled. So some of us didn't get the information about that class, and someone like me, I was not there. I was not I was not present because I didn't get the information early enough that the class was still going to hold. So I don't know. I didn't learn all those things she just mentioned. Thank you.
All right. Yeah, that makes sense. So anybody else? Okay, I think that's fine for now. That's fine for now. So I would start with integers, right? I'll start with integers just to carry everybody along. I'll start with integers, then we'll walk up from there, and also we'll take consideration of the time. So we'll try to um just be as fast as we can. And also, no matter how fast I say we should be, feel free to ask questions because I feel like the goal of this is for you to be able to get something. So if you're just fast and you're not getting, then there's a problem. So anytime you um anytime you want to, if something is not clear to you, please feel free to unmute yourself and speak. Especially when I'm demoing a coding screen because I might not even be on the same like on the meeting screen. So even if you send a message, I might not see it. I might be like on remix trying to show you code. So unmute yourself and call my attention, and I would do my best to answer you. So quickly, let's just get started. I'll share my screen. Yeah. Can you see my screen?
Yes.
All right, all right. Yeah. So last week, were you giving slides? Okay,
No, we
Elizabeth.
weren't.
Okay,
No, we
okay.
All
weren't.
right.
Before you start, please, I want you to explain that SPDX license. It gave me quite an issue, and I had to start googling what it means before it was able to compile my code. So please
XPDX.
explain it as well. Yes, the
The
SPDX license identifier.
oh. Okay,
Mm.
so
What exactly
basically,
does this concern?
basically, all Solidity code is meant to be open source. So and when you start talking about open source development or open source code, then you bring in license. So basically, they are trying to tell you what you can do with this code and what you cannot do. You understand? So even if you see open source code like online and you can easily go to GitHub and get it, or even go to Etherscan, which is a block explorer, we actually need to know what we can do and what we cannot do. So basically, this XPDX identifier tries to specify the particular license that this Solidity contract is running on. So, for instance, speaking vaguely, you can think about how some contracts can be used for commercial cases. Like I can be able to, like based on the license, I'm allowed to take your code and use it for something commercial and like use it and try to make money. And some you can't, you understand? Even some you specify no license, you get. So basically it's trying to tell you the license that this code uses. So you might not really bother about that, but if you want to really use a contract or something very serious, it's probably go and check the contract, the license that is specified. But I've not really seen many cases where they even think about that thing a lot. But basically, it's just trying to tell you so you don't go to use code that you're not meant to use and probably get in trouble. So yeah, that's it basically. Does that make sense?
Yes, it was because Remix kept specifying that it's not going to compile until I put the SPDX license identifier.
I
So I
think
had
it's
to
not
just go online and search for one. It's not called. I think the way they updated the latest remix, if you don't put the SPDX identifier, it will not compile. Mine wasn't compiling. It kept giving me error message that I must put the SPDX license. So that was why I'm asking.
okay.
Yes,
Did
even
it?
mine too. I had the same issue. They said I had to include that XPDX license.
Well, it was the error like this.
Yes, this was the error. So the compilation wasn't happening. So I had to go and search for I mine was MIT, so I don't know. I think they have various. We don't even know which one to use for which. So I just used the one that has SPDX license identifier MIT, and luckily the error went away. So that was how
So
I was able to compile.
yeah, that makes sense. So there are like two types of errors in Remix. So this one I'm showing now would not allow you compile. This is red, right? But this is yellow, which is more like a warning. So I should still be able to compile this code after removing that. So let me just show you something quickly. So so this is a warning and not like so I can this has already been compiled, right? And I can easily deploy this, and this is a number test. So this actually compiled. So probably that was the error you were seeing, and you say like it's actually going to compile, but it's just a warning. It's not really an error per se. When it shows yellow, it means that they are telling you that check out this thing, no, check it out. And most times, it's not really good to leave any error untouched, but that doesn't mean that it wouldn't compile. You understand? So probably it was showing this yellow one, and like it's an error. Like, you understand? Nobody likes an error, so you probably just. But yeah, it will actually compile. It will actually compile. You get?
Okay, thank you.
Yeah, or if you're seeing it too much, you can just decide to do this. This thing, if you read what they're saying here, like I can just come here and change this to unlicensed. No. That is spelling. Let me read the error. I can get it spelling because that's what they're actually saying here. That for publishing, blah 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 blah. Use this on license for non-open source code. Okay, for non-open source code. So basically, if you don't have any, if you're writing yours and you don't have any open source license in mind, you can just take in unlicensed and put there. So let me just try this. Yeah, so this works. You see, so I just put unlicensed there and I'm not getting an error, any warning rather. So yeah, so that's that for the license. So let's start. I want to start with um integers for today. Let's start with integers and we'll try to go and try to cover as much as we can. But also, before I also go ahead, the thing about this coding is that even if you spend a lot of time trying to explain something, you would always get more as the student. You always get more from going to do research. It's very, very, very important. Do you get? So, in as much as I would try to talk about these things and explain them as best as I can, at the same time, when you go ahead and try these things out yourself, you start exploring. You start seeing things that I probably wouldn't have like said or wouldn't have been able to say. You understand? So just take note. Just always try out these things yourself and explore. Understand? Even come and ask questions of things I did not teach or have not taught, and we'll try to figure it out. If I don't know it, I'll tell you I don't know it. But at the same time, we all have an opportunity to learn. You get. So yeah, let's start with integers. In Solidity, okay, I'll try to break this same code into integers. So in Solidity, there are two types of integers. Okay, let me just use better comments, multi-line comments. Okay, so there are two types of integers, so signed and unsigned. I guess people that were in the call last week must have talked about it. Signed and unsigned integers. So the basics of this, the fundamentals behind signed and unsigned is quite deep. It has to do with the range of numbers it can carry, like the range. So apart from the fact that what you would hear is one takes in negative, one can take in signed numbers, which is positive, a number that has numbers that has like, okay, let me just write that like +2, -1, stuff like that. So something like this. So this can take in something like -2 and like say +6. You get +6. And the other one can only take numbers that are not signed, so stuff like that. So integers, you understand? So mind you, I said integers, so it can't take something like 5.0 or 5.1 or 5.2. Like you can't take floats. Basically integers, just integers. You understand? So they are like integers, they are rational numbers, they are irrational numbers, but this can only take integers. So that's the first thing. But something you have to understand is on a fundamental level, there's something called overflow and underflow, which is basically what happens when you try to exceed these ranges that is like when you try to exceed the ranges that they allow. So probably later, at the end of this call, I'll send you an article I wrote about overflow and underflow. But it's interesting basically. So let's just go ahead. So in Solidity, if you want to define an unsigned integer, you use this, and let's give it test int. Basically, this is an integer. This is a number that can carry from 1, I'm taking from 1 to 2 raised to power 8 minus 1. Okay, basically, let's just see it, because these numbers now, they have the minimum they can take and they have the least they can take. And these integers come in different flavors. So now, what this means, this uint is the same thing as uint 256 first int. So this is the highest it can take. Okay, let me remove this one. They're telling me that they're having the same name, so something you would probably find out if you just play around with these stuff. So now this comes in different flavors. So
sorry for distracting you. Can you zoom in? I can't see anything.
Okay. Oh, this was okay. Let me try to. What does this? Is this better?
Yes, it's better now.
Right. So we have this in all flavors that are multiples of 8. So you can think about it like this. There is uint 256, there is uint 1 to 8, there's int 3, there is uint 64. I said multiples of 8, right? So don't mind me that I'm just dividing by 2, but just multiples of 8. A lot of numbers are 8 can go through. And then the lowest is uint 8. So I want to show you something. Like these numbers, what differentiates them basically, or rather these different types of unsigned integers, is the amount of values they can, like the range of values they can take. So I want to show you something now. So let me show you the maximum number that one of these can take. So let's say max. I would share this. I'll share this contract when I'm done, so you can just go through it yourself in case you miss something during class. So unit 8 max. Let's see this unit 8 max, and let's also see unit 256. Also, always remember at any point if you don't understand anything, please do well to for my attention, so we can just talk about what. So this unit 8 mean I want to show you the highest value these numbers can collect and the lowest they can collect. So just so that you understand why they have these numbers in front of them, because if they could collect the same numbers, the same range of numbers, then there will be no need to have them in different flavors like this. So I remember uint is an alias for uint 256. So in case I just put uint and not 256, they are the same, uint and uint 256. So it's the highest. So you can put in a number for like 8, which means that you're taking a subset of it and adding. So it's not a problem. But if you want to do it the other way around, like if you want to take a number for uint 256 and put it in uint 8, you would have something called an overflow error. But we'll get to that. Or rather, I said I will send an article that talks about the maths behind it. So don't mind me, I'm saying maths. It's not that I try to explain it as much as I could, and I'm sure You just need to understand basic plus and minus to understand what I mean. So I'll get there coming. So mean, so I want to show you. So this, you just take this. So this type is an in-use function that comes with solidity. So it shows you the type. Then you can now use something like this max to see, to store that in there. So we can just see it. Unit 8 max. Same here. Unit mean. It's mean. So now there's something missing here. Okay, let me tell you what I want to do, and I'll ask if anybody can tell me what I need to do before I get to that place. Now, I've defined these functions and they are all attached to one variable, but I want to be able to see it when I deploy it without calling it from a function. So let me say that again. I want to be able to see uint 256 max, uint 8 max, uint 256 mean, and uint 8 mean when I deploy it without having to call it through a function. So can someone just quickly tell me what I need to add to these functions to be able to do that?
I think public.
You have to make it public.
Thank you very much. So yeah, so that makes sense. So basically, we add public here so that we will be able to see it when we deploy it. So what this does basically is that it gives you a getter functions, a getter function rather. So basically, it gives you a function that is a getter function. So it just basically gives you a function. So rather than having this, it just gives you this. Just gives you this. Yeah, just gives you this, and you'll be able to use this to call. So yeah. So let's deploy this and get the values quickly. Oh, okay. Let me remove this one I deployed before. So yeah, let's deploy it. So we've deployed this, and let's start from the uint 8 max. So this is uint 8 max. Now, this is what they told you that you'd be able to do, you'd be able to get the highest value you can store in uint 8 is 255. And how did they get that? This is what they did. So what I showed, this. Exactly. So this is what they did here in uint 8 max. So 1 to 2 raised to the power 8 is 2 raised to the power 8 is what? So let me quickly check that. So yeah, 2 raised to the power 8 is 256, right?
256. Yes.
Yeah. 256 minus 1 is 255. So that is how they try. That is the little maths behind what a number can store and what it cannot store. And now you might be asking, why is it that we need to use this in different flavors when we can just decide to use the highest one and get all the numbers? The reason behind this is that compiled languages, they kind of they prepare the runtime before the code starts. So how this works is, if you declare a variable as 256, it creates a space for a number that's up to 256. But when you now start to store little numbers inside that 256, you are kind of wasting resources, basically. So if I want to just store one and I use 256 for it, the compiler already created memory space for large number, a very large number, and what I'm using is just a small number. But this just talking like from a general programming perspective. There might be specifics of why they do it in Solidity, but this is just talking from a programming perspective, but this is not the only language that implements stuff like this. There are other languages that do stuff like this. So that's that. So let's check the marks for others too. So marks of 256. So this is a very large number. You understand? But it's just basically the same thing, but using this. Or using 256. You get, so this is how they got this one. They used the range of 1 to you get, sorry, 1 to 2 raised to power 256 minus 1. Yeah, go ahead, Ogechi.
I want to ask, if that is the case, shouldn't we just have it as 1 minus 2 raised to power n, given that n can change, the value of n can change? Because when you leave
Exactly,
it at 8 that way, I was almost getting confused.
exactly. So yeah, I think you know maths. So but yeah, that makes sense. So just n, then you just put it in there. So I was trying to be specific, but yeah, this works too. Understand? You just replace any number in front of it with this to get the range. But it's not like you need to know it, but I just want to tell you, you need to know that you need to know all these things of head. But you just need to know that there is a reason why they are doing this, and there's also a reason why there's an idea behind it. Okay, did your hand stay up?
Sorry.
Oh, no, it's fine. So let's go to the mean. Let's go to the minimum. Okay, the minimum is always like, so far it's an integer. It's always, no, it's not 1, 0, sorry. But yeah, the minimum it can carry is 0, and the minimum this can carry is 0. So basically they are just coming, they can take 0 up to their max. So which we know that for a number as small as 8 is 255, but when you start going up, you can't really start cramming that. But yeah, this is the formula to know that how this works. So yeah, but I want to talk about
Are you
things.
saying it's no longer one? Okay, it's from 0 to
Yeah,
2
that
raised.
was a mistake. So it's 0 to,
Okay.
yeah. So I would like to talk about constant and immutable, but I don't know if that would, okay, let me just talk about it. If you don't understand, then I would, okay, don't worry, let me just go the normal round because it might be confusing. So that is that for unsigned integers. And unsigned integers can perform different operations. Operations we know about, like plus, minus, like addition, subtraction, division, multiplication, and yeah, a lot. So you can also apply like bitwise operations. You understand? You can apply some bitwise operations on it, but I wouldn't want to go into that now. But yeah, any operation you think about that you can perform with numbers, you can perform it with integers. Most likely, in as much as solidity is kind of, it's built somehow, not like other programming languages, but any operation you think about, it's likely that you'll be able to perform it in solidity using solidity integers. So let's talk about unsigned integers. Okay, is signed sorry, let's talk about signed integers. These are unsigned integers. It seems like confusing sometimes. These are signed integers. So let's talk about unsigned integers. Sorry, signed integers. God. Yeah, signed integers. So now the main difference between signed and unsigned is that signed can take both normal numbers and numbers with signs, but unsigned can only take numbers without sign. So let me just quickly take this, copy this, and test it out so you would understand what I'm trying to say. So now what changes is, instead of viewing int, you have int. The same thing, basically just change everything to int. Basically just change everything to int, but it's basically the same thing. That's giving me an error because I'm using the same name. So, oh, okay, let me just change this to test uint, not int. Yeah, test uint. So remember, at any point, if you don't understand, please call my attention. Let's quickly talk about it. So it's better we kind of clear everybody than try to rush to the end, and at the end a lot of people are not understanding. Okay, why is it still giving me errors? It's not implicit convertible to. Now they're telling you that these numbers right now, this particular data type can't take in unit. So it's not like it can't take in, but at the same time, you can't convert it in implicitly. So there is something called implicit conversion and explicit conversion. So implicit conversion is that thing in JavaScript whereby you write 0 plus 1 as a string and it gives you 1. So JavaScript is inferring that if you have 0 and you have 1 as a string, that you probably want to use 1 as a number. So it just does the conversion implicitly and it gives you 1 as the value, as the answer. You understand? So, but they're telling you that you can't do it here. They are not helping you to do any conversion. So be very sure what you want because they will not do the choosing for you. So basically, let's just come here and change this to, when you change this, at least that one is gone. Change this, and yeah. So that's that. So let me just redeploy this and let's see the min and max is of these numbers. So let's start with the maximum of 8, int 8. Yeah, so let's go int 8, int 8 max, int 8 max. So this is 127. So this is how they did it. So instead of this, they did they did times raised to power 8 minus 1 minus 1. So let me just, don't worry. In case you're scared of math, don't worry. I'll try to make it very simple. Math is interesting, by the way. So instead of 2 raised to power 8 minus 1, we now have 2 raised to power 2 raised to power 7, then still minus 1. That means we have 2 raised to power, then bracket of 8 minus 1. So instead of just doing 2 raised to power n minus 1, we now have 2 raised to power n minus 1 minus 1. And that n minus 1, it is in attached to the power you want to use. You get, so let me just use this. So this is equal to 0. Let me use 2. Let me not use this. This looks like minus. So okay, go ahead, Yama.
To make it easier, I think n minus 1 should be in its own bracket.
Yeah. Okay, in its own bracket. Oh, okay. That makes sense. Okay.
Yeah.
All right, yeah. Thank you. So this now converts to 2 raised to power 8 minus 1, then all brackets minus 1. So this basically means 2 raised to power 7, 2 raised to power 7. 2 raised to power 7 is 128. So 2 raised to power 7 minus 1, so 127. 127. And that is this is what they give us. So let's check the mean. The mean of this right now is not
Sorry,
okay.
sorry to
But
cut you off. My hand has been up. I've been raising my hand, but you weren't saying.
yeah, sorry.
I I don't know. This sorry. Can it take? I thought it can take both positive and negative numbers.
Yeah. We'll get there. We'll get
So I was expecting to see plus or minus sign used instead of all this just negative signs.
Okay, in when you say plus or minus. Okay. This is just the max. I just brought out the max. So the max is 127 as a positive number.
Okay.
So when we see the mean, we see that it's a negative number.
Okay.
Yeah. But I understand you, but just see the mix, then you probably the mean, then probably so the mean is minus 128. You get so now it can take from minus 128 to 127. And you know, after 128 to minus one, after one minus 128, you have minus 127 up to 0. Then start counting all over up to 127. You get so it can take in from the lower bound up to the higher bound. You understand? So that's that for this. So let me also show you how they get the lower bound. Okay, let me bring up the article right now. Because I talk about it. Okay,
Okay, I
Elizabeth.
have a quick question.
Yeah, go ahead.
Yeah, you didn't give us the range of the mean for UINT as well. I thought it was the same value we were using.
The range for the
The
minimum
mean,
value.
the dot mean. Yes.
Oh, yeah, I think I showed it now. It was all zero. It was all zero.
No,
Like the mean for unit 8 and the mean for unit 256. I think I showed that,
zero
but not
throughout.
it's
Yes, you
zero.
did. You said they're all zero.
Yeah, they're zero. So basically all positive numbers and it starts from zero. So that's that for the mean of these unsigned integers because they cannot take negative. So they all start from zero. Yeah. So this is the article I'm talking about. I just want to bring up something from here. Yeah. So to get the minimum number, what they did is they did okay, let me send this thing and probably later just check it out because I think it's really interesting how these things work under the hood. So this is the article, but I want to show you how the mean, I said the mean for units, they are all zeros, but the mean for signed, they have a formula to use. So let's just quickly see how they check that out. So see how they solve that right now. So basically what they do is instead of this, they now use instead of this, they now use minus this. Okay. So now they don't do this part anymore. And they just change this to minus. So instead of 2 raised to power 8 minus 1, that is 2 raised to power 7 minus 1. They now do 2 raised to power 7 without doing the minus 1. So that's why, sorry, yeah, okay, yes, this is, yeah, so they now do this. So we now have 0 to minus 2 raised to power funny enough, I just forgot where my card is in my keyboard. Interesting. So they now do the 8 minus 1. Okay, please go ahead. I did.
Okay, thanks. Just a quick question. So I know that on VS Code, I can wrap my code Alt Z. Is there any way I can do that on Remix instead of scrolling left and right?
You can wrap.
Yeah,
You can wrap.
on VS Code, I can wrap my text, my code Alt Z, so I don't have to scroll left and right like you are doing. But I try that on Remix. I don't know if
Okay.
that's possible. Any
Yeah,
idea?
I don't really know how to do that.
Okay, okay. Okay, thanks.
Okay, so then so this basically is 0 to -2. So in case you know this thing, just allow us, me, I don't know it to understand it. But yeah, in case you feel you know all these things, just for the sake of people that don't know, because what I've understood over time is that some people are like on the both ends. Some people either know it or they don't know it. You get, and some are in between. But just for the sake of everybody, let the people that have learned it before relearn it. Yeah. So 7, then basically -1 to 8. You know, if you use if you use a number, if you use a negative number and the power is an odd number, you'd get a negative back. So that's why. But this, as many this was an 8, this will clear out this negative, but isn't a. But yeah, that's that on this. The same thing I said for this, you can perform almost all operations, if not all, from addition and subtraction up to bitwise operations. So at this point, does anyone have any question before we go ahead? Or do you understand fundamentally how this works? The units and the unsigned integers and the signed integers. Okay, go ahead, Elizabeth.
Okay, so far I've understood what you have explained now, but my issue is going to be when we start coding because
Okay,
in the assignments that we were given, I tried using a UN
okay,
and an error kept popping up like I wasn't calling the function of the unit, the UN, the way it's meant to be. So I had to remove it and change it into a struct, a string, because I didn't know how to input and call the function of that UN to perform a function in my code because I'm completely new to this. So maybe when we start the coding process, I'll be able to understand how we can make use of this in calling a function when we want to use the unit.
okay. So I think because it's an assignment, what can you explain what we were trying to do and what the error you got? Then we can let's just try to see if we
Okay,
can.
I was trying
Because
to. Okay, they said we should create a data for a student showing an
okay,
identification and the like. So I wanted my identification number to be in an integer, to be in
okay,
numbers. So I was using a UN. So when I was now calling the function, the Mix was telling me that the UN function I was calling was wrong, that I wasn't calling it the proper way and I didn't know how to call it. So I just changed it into a string, the identification into a string, which means it's going to be like in the form of alphabet because I couldn't use numbers since I couldn't call the UN.
so I would have loved to replicate that, but I don't know if okay. Let me just so were you trying to do like something like this? Let me see. I just a normal stuff like this, or can you just write? I don't know. I want to be able to replicate exactly what you did, and let's just see if we can
Yes,
solve that.
I was like, okay, we were meant to have. So the first code was that I'm coming up with check how I wrote it. Okay, so we're meant to use a mapping, we're meant to use struct. So for the Ewing, I was trying to use identification for my Ewing, and we're meant to use enum as well. So I was able to get the mapping, I was able to get the enum, I was able to get the struct, and how, based on an example video I watched, I was able to get how they call the strings and store them in the memory using the string name of the variable. So now when I was
Okay.
not trying to include the unique value in that function, because in the function I said, okay, if you have a function and we call string memory first name, we know that it is a string, it is a first name. So I was trying to say unique memory identification. It was telling me that there is an error, that that's not how they call it. And I didn't know how to call the Ewing after I had included it in the struct to perform a function. So I had to change it entirely from the Ewing and make it into a string because I wanted it to be in numbers before the identification number. So how do you call the function of the Ewing after you've given it a variable name?
So can you explain what you mean by calling the function of a unit?
Okay, let's say like now the way you wrote this Ewing public test norm. Now, if
Yeah.
I want to include it in my list of data, how would I call it in a function that it should include it? Or because it wasn't showing immediately I wrote the Ewing public, it wasn't showing when I deployed. It wasn't showing where I wrote identification. The identification of the test norm, I gave it the value of identification number and then included it inside my struct. I don't know if you're
Oh.
understanding how.
Okay. So you use it inside a struct.
Yes, after first of all giving it a name like this, then I included it in a struct so that I'll be able to call it in a function.
Okay, I'm finding it hard to. But let me see. Let me try something. So struct test data. Let's give it first name. Is it something like this?
Yes,
Something like this. Yeah. So
yes.
so when you say you're trying to call it, what were you trying to do? You're trying to get age from the test data.
So as it is now, I would now say I call a function. And
To
the
return.
function, in the bracket of that function, to return the Ewing data when I deploy, so that anybody who now wants to input, you can give a value to that Ewing data of age.
Oh, okay. Interesting. Let's just try it
So,
out. So let's.
so how am I going to call a Ewing in a function? Because Unix was telling me I wasn't calling it the proper way and I didn't know how to call it. So I had to change it to a string.
Okay. So let's just try something out. So let's try to add data to this struct and return it. Okay. You know, there's this thing about struct where this thing itself now is just like an interface. Okay, because of use memory. Okay. Messi, please, can you like? I saw you were raising your hand before. You want to talk about that?
Okay, according to what she said when she was calling it in the function, she said unit memory age, something like that, right? Elizabeth.
Yes,
So
yes.
so that is why it wasn't working. You use memory for only string in Solidity. You don't use memory for unit. You just call it like in the function. You just call it.
Okay.
Um, you just call it unit 256 or unit
Okay.
8 and
I
then
won't put
age.
the memory
Yes.
there. Okay.
Oh,
Yeah.
okay.
Eh,
Yeah, yeah, yeah.
Okay,
That
okay.
that
All
makes sense.
right.
Okay,
You are
now
trying,
I understand. I actually had the same problem. I had the same problem too.
yeah. So use memory for strings, use memory for arrays. So you don't use it for integers. So should I still go ahead or are you there? Like, should I still go ahead and try this out? I'm not even sure I'm replicating exactly what you did, but should I go ahead and try it out? You're clear on that?
We are learning, guys. I'm actually new to it, so it was thanks to a video I was able to do that.
Okay, okay, okay. So we know we've not reached here, but just follow along. If you don't understand, it's fine. Just call. So basically, we created a struct is like an interface. So if you've ever used TypeScript or you've ever used a language that has uses interface, I think yeah, Java or something. So what interface does is they try to tell you how your data should look like. Just like you're working with an SQL database, they'll tell you that column one is first name and the data type is string, and column two is age and the data type is something else. So age. So now the struct basically just tells us how we want our data to look, but it won't store data, right? It's just telling you how your data should look. So I want to create a mapping that would help us to store each user's data. And we want to use so a mapping is like a dictionary per se. It has a key and it has a value. So I know I'm going way past what I was doing, but just follow me. So a mapping is like a dictionary if you're using Python, or it's like um an object. Okay, object is too vague. An object in JavaScript, but let me use another word. What is this called? That skipped my mind. But if you use Python before, you know that just like having first name equals to this, age equals to this equals to this. So it's a one-to-one mapping. So we want to make the key a number, then want to make the value a test data. So now this could actually store data for us. You get this could actually store data for us. So not like just using the test data only tells us how we want data to look, but it doesn't really store any data. So let's just give it users. I think this is intuitive if you just think about it, how this works. Yeah. So now we want to be able to see it from outside. Want to be able to see it from the outside. That's why I added public. Something else you should understand is that in mapping, you can't get all the data except you look through it, or you would have to get it one by one. So if I come here now, I'll have to use a number to find a particular thing. So also, let's create a variable to keep track of each user. Just like a database, we want to be able to store them using their ID. So we have user one, user two, user three, user four, and stuff like that. So I want to create a variable called count. So as we are counting them, we are giving them their IDs. Do you understand? So we are saying if it is first user, let this ID be. Chairman, I want to say something.
No, sorry.
All right, it's fine. So we have a count, which is basically I'm saying as I'm counting them, I want to be assigning them numbers. So IDs 1, 2, 3. So in Solidity, this is assigned a default value, which means that this automatically is 0. You get this is 0 already. So this is already 0. So now we have an error. They're telling us no visibility specified. So basically just like we did here, public, we have external. Sorry, give me a second to comment. Yeah, sorry about that. So now we need to use visibility specifier. So I know you've talked about public, but have you talked about do you know what external does
Yes,
instead of
that you
public?
can use. I think you can use another contract to call your contract.
Okay, the way like public just tries to tell the compiler that we want to be able to call this function both inside and outside. But if you use external, you cannot call this function inside the contract, except outside the contract or inside another contract. So that's like the main difference. If I use public here, I can still call this user inside inside this function. I can still call it somewhere else inside this contract, and also be able to call it in a contract that is inheriting this, which we'll get to later. In a contract that is inheriting this, you get. But when I use external, I can only call it outside the contract, which is whether you're inheriting the contract or you are just calling it from here, like the outside, complete outside. That's just take note of that. Yeah. So let's just quickly create data. So okay, let's take in the data. So let the user pass data. String memory. So you can either use memory or you can use call data. But they mean different things, but let's just stick with memory. Probably when we're explaining that, we'll explain what they mean. But yeah, memory, give it first name. So the underscore does not mean anything, it just means I like doing it like that. So just I like using like underscores for local variables, which they are. So this is a function argument, so it's local. It doesn't go past the function. It does not cannot be used outside the function. So I like using it that way. So just in case. So age, you have um you have a struct type. Sorry, okay. Okay, sorry. So this test data. Let's give this test data, and we can give this test data. This takes in the first name, this takes in the age, and this takes in the test. Okay. Okay. So they want us to use memory. So okay, sorry, they want us to use. So here they want us to specify if this is if this is used this way, then it means that when we are manipulating the data, it is just in the context of this function. So when you finish running the function, nothing changes in the global state. Okay. So the way external works is that if you're using external, if you specify a function as external, because you cannot use external here. So let me just show you something. If you use external here now, it doesn't work. This getter something I explained here is it only works with public. Understand? Only works with public. So I think let me try something. Private. It works. Internal. It works. So sorry, don't worry about that. So external doesn't work for this first of all. Then I said if you use external, you can only use that function outside the contract. That is where whichever you're doing, you're probably either trying to you are trying to call that function outside, just like we're calling these ones here, like when I mean outside, or we are inheriting, we are taking from, there's something called inheritance. So we can use this function now. So we can use this contract as it is like this now inside another contract, but we'll get there. So we can only use it here, or we can use it inside a contract that we are inheriting, that is inheriting this particular stuff. Understand? Do you get me?
Yes, I am.
So okay. So let's go ahead. So now we've created the data. So okay, let me see what they're telling me here. Okay, so what they are saying is they want me to add something called what is it called? The I've forgotten what it's called. But basically it's pure, it's either pure or it's view. But we'll get there. We'll get there. So now I want to add this data into the user's mapping. So we've created the data first. I want to add it to the user mapping. So now we do user. Okay, because I want there's this thing I like doing because I want the count to start from 1 and not 0. I do count, I increase it before adding it. You get. So assuming I just wanted it to be 0, I'll probably okay, wait, let me show you something. So these users goes to there's data. So this now adds data here. But assuming I wanted it to start from 0, no, I think this is man, you already I think you already understand what I'm saying. I'll just do it after. Because I want to start from 1, I don't want to have a 0 in my little database. So now what this does is I adds a new data, right? So let's also create a function that returns this data. I think probably then we'll be able to understand. So then return data. Then we'll take in the ID. We'll take in the ID, which is let's just call it ID. Okay. Aisha, okay, you can go ahead. Aisha, you can speak. Okay, all right. So let's return age. So I want to return like I'm trying to see if probably derailing from what she asked for. At least we're trying. So um let's just get the values from here, picking ID, then want to get the age. We get. So now, okay, sorry. So if you want to return, you need to specify that you're returning. So returns unit. I think they should solve that. So this will be a view function. So basically, how view works is that if you use a view function, so far you're not modifying anything in the state. When I mean state is like the general state of the contract. So the state variables changing, like these variables now, when they change, then you've done something, you've changed something. But when just things that were created inside the function changes, nothing really happened. But here now, we know we are changing the state because we're adding a new data here. But here now, we're not changing anything. We're just getting, understand? We're just getting data. But assuming this was pure, assuming this was pure now, then in using pure, you're not even meant to call anything. You're not even meant to. So if I change this thing to return one, there's no problem. That you see the error has removed. You understand? But if I change it back, there's an error because they say with pure, you're not meant to change state, and you're not also meant to call anything that is in the state. You understand? So that just by the way. It's fine if you don't understand. I'll still get okay. Please go ahead, Aisha. Yeah, you can go ahead. Can you hear me? Okay, I don't know what the issue is, but don't worry, if you're able to speak, just speak, and I would tell you if I'm hearing you or not. But yeah. So
Sorry, please, can you hear me?
yeah, I can hear you. I can hear you.
Okay, I want you to explain something. The add data function. I didn't
Okay.
get that users count. The last thing you the count and then the plus plus. I didn't get that part.
Oh,
Yes, there.
I forgot to explain this. So this plus plus is the same thing as count plus one. Yet because incrementing is normal in programming. So programming language have this syntactic sugar, basically, if you want to call it, just trying to make it easier to do. But it's basically this is what I meant when I did count plus plus. So this makes it easier. Just do plus plus. Or if you want to minus, if you want to reduce by one, you do minus minus. But basically, that's what they are trying to do. Also, the ID thing, I said if I came here now and if I took this thing here, just if I had taken this thing here, right? What will happen is, this value is already zero, right? So when it comes in here, it sets the first user as zero, and then it increments it by one. You get increments it by one, so that the next user coming will take a one, then and so on. But it starts from zero, which I don't want. So that's why I took it above. So that even before it starts, to first increment to one. That means the first user will have a one, but it will first increment by one. So does that make sense?
Okay, I understand it.
Okay, makes sense. Makes sense.
Please, can you
So
hear me?
that's telling us. I can hear you. I can hear you.
Sorry, I've been trying to speak since, but I think the laptop of my sister is faulty. I mean, the speaker of my laptop is faulty. So the point where you said test data memory underscore test data, I just wanted to understand that test data, that underscore test data in front of it. Is it like a variable at that point?
Yes,
That
it
underscore
is.
test data. Yes, that is holding the value test data. That's the struct value coming from test data.
Yes, yes.
Okay, okay, thank you.
Okay. So yeah, like I said this struct basically is defining data that it is not actually like it doesn't store anything. It's just trying to it's just like there's something called the database schema. I'm trying to tell you the kind of data that database will store, but that in itself doesn't store data. But now, if you want to use it, so that's why we wrapped this first name and age inside here. They will not created a variable. You understand? So that what it does basically. So it creates a variable with this, and yeah. So this memory, we can either use storage, but so I said that memory means that anything you're doing, it is not altering state. But when you use storage, it's altering state. But let's see the error because this thing is not even really outside. So let's see what they're saying. Exactly. So now they're already telling you that, first of all, this thing is not in the state. So even using storage here is wrong. So that's why they're telling you that. Okay, sorry, let me go back. So they're telling you that test memory is not implicitly convertible. How do I read that in full now? Well, that's by the way. But basically, this test data, it is not in the state. So when you're using storage, you're trying to tell it that when you're editing it, it should like that means you're trying to edit what's in the state. Meanwhile, it's not even in the state. It's just like a schema per se. So let's just send this back to memory. I think using core data works, but I'll explain core data later. Okay, it doesn't work. So they're trying, okay, it's still memory, it's not even core data. It's still memory. So core data. So now let's deploy this again and return uh, add data. So Gauss power page. Okay. So let's try to add this data. Let's see what it does. So it has added the data. So now this should have a variable of a count of 1. So if you put in 1 here and we return it, we can get the age. You get Elizabeth, is this how you did it? Because I think we very derailed from what you asked, but
Yes, that was how I did it, though I don't understand most of those functions. But my issue was being able to use the UIN in the function. So I think it has been rectified because I added memory to the UIN, so it was telling me error. So if I actually
oh,
remove that memory, I think the UIN will have really worked for my identification.
okay, okay, okay. So yeah, basically. So let me talk about something else because okay, before I go ahead, are we clear on units, like on signed integers and unsigned integers? Are we clear on that? Please, just any question you ask is valid. Just ask your questions.
Please, can you go back to it? I just want to get a screenshot of the functions you just finished doing.
Which, sorry,
The add data function. Can you just
like this?
yes, please.
All right. So that's that.
Okay.
So yeah. So the reason why I'm not holding back when I try to explain other things that you've not been taught is because of I want to explore this thing. So assuming we are strictly just following this line, I'll probably not even talk about anything apart from what we are talking about. But in as much as it might confuse you, but I just want you to know, just so that you just be getting some like ideas about things that we've not even thought. You understand? So your limitation for not trying something out should not be that you've not seen it before. At least I'll be saying things that I've not talked about before with the intention of talking about it later. And also you just, at least when you're trying things out and you see view, it's not just be like that thing you've never seen before, do you get? Or you see external or you see pure, that kind of thing. So let me see the next, I want to talk about mapping. Okay, I think I already talked about mapping. Why talking about the gains? But let me just talk about it again. Let me use this example that we already have already existing. Okay, something else. I was using 2 screens before. Now I'm using 1 screen. So I'm not on the screen of the call. So if you want to ask, don't send it chat, just unmute yourself and speak, please. Thank you. So the way mappings work is a key value pair. Is a key value pair. You understand? So basically, you're saying that you want to map a key to a value, like I said. So here, I think this looks intuitive. We are trying to store users of our hypothetical contract or our conceptual contractor. We don't even know. But we want to store users. You understand? So we are storing users. So we need the key and we need the data.
Excuse me. Can you
Okay,
please
okay.
zoom in your screen?
Okay. I think I did that before, but let me try. Let me see. Is this better? Is this better?
No, like a little bit more, please. Thank you.
Okay. Um, this is better, right?
Yes, thank you.
All right. You're welcome. So, like I was saying, so basically, it's just a mapping of a key to a value. So what we did here basically is we defined what this value should look like, and we used the key of number. So we can also do the same thing using something else. So we can do u into You can use U into string. You can do U into strings. You get, you can do U into strings, or I even do U into another mapping. So you might want to have like a mapping inside other mapping. So you can just do something like this: mapping U int, and you now have another mapping of address and viewing. So imagine we wanted to store the balances of users. So you understand. So this works. You can have a mapping inside a mapping. Understand? So just like the best use case for this I've seen so far is using in ERC20 tokens, right? Or NFTs. But okay, ERC20 tokens. So I think NFTs, but the store okay, no. When you want to store the number of people approved to spend your token, don't worry about that, but the number of people approved to spend your token in an ERC20 token. So but what we do is that we store the address, then we now store the address and the status. So let me do it. So let me call this thing approved. This is a real life use case that's currently being used. So you do address, then you now have a mapping, then we now have the status. Well, I know when I talk about status, I'm talking about booleans, which is yes or no, true or false, stuff like that. So approved. So this is how it's used in yeah, it's used similarly in NFTs. Yeah, so basically this is my address, and this is the address of somebody approved to use to spend my token, which is like OpenSea, Foundation, all those NFT marketplaces, because they should be able to spend the token for you now, that kind of thing. So they should be able to spend your token for you, and now we are storing their status. So if they finish spending and I don't want them to spend again, I would call a function that changes this to no. Understand? Rather, sorry, change this to false if it was already true, but by default it's false. Understand? So yeah, mapping just helps you to store key and values, and you can always get the values using the key, but you can't get all the data. Understand? So in languages like Python now, that's why I said solid is built somehow. Language like Python, there's a function called dot values. If you have a dictionary, you do dot values, you can get all the values. Or if you do dot key, you can get all the keys. Or you can even try to just print out the whole dictionary. But here, we don't do that. We don't do that here. So if you want to do that, you can just write a loop. You understand, inside your function and loop through everything and probably store them inside an array or something. But loops are dangerous because of gas. Because if you have an unbounded loop, then you are likely to run into a problem with gas if you don't have enough. So if you have a bounded loop, then it's better. When I mean by bounded loop, is a loop that you don't know when it's going to stop. Understand? If you do for I in n and somebody put that n as 1 million, there's a problem because you are probably going to run into gas. But if you set that n equal to 10 from, like, if you set it statically, then you can always know that okay, you can always have enough gas. But when the loop is not bounded, it does not have an end, or you don't even know the end, then there is a big problem because you are likely to run into issues with gas. Your gas will finish and it will revert, everything will revert, and you lose your money. You've not done what you want to do. So that's by the way. So yeah,
One question.
okay, please go ahead.
Is it only UINT and address are the keys that mapping can hold?
Okay, let me see. Let me use string here. Okay, that's a very good question because let me see if it can work, because I've not actually most of the times we use this, but let me see. Okay, it works. String works. Understand? Let me see if I can. I'm not sure I can use a struct. I'm not sure, but let me try a struct here. I'm just using the test data I used before. It's unlikely it doesn't work. Let's see the error. Only elementary types, contract types, or enum types. Enums are allowed as mapping keys. So these errors are very helpful. Something you will not see if you're coding on VS Code. So yeah, you can use, they say only elementary types. So we're talking about, they said contract types, enums. Yeah, so you can use strings. You can use units. Okay, let me see if you can use Boolean. It does, to me, it doesn't really make a lot of sense to use Boolean as a key, but let me see if it works. Because the idea of keys is that I think you should be able to differentiate them, but there's only true or there's only false. Yeah, it can work. Okay, no, let me change this to 3. Wow, it actually works. But can somebody just quickly tell me the problem we'll run into if we use this? Or rather, let me just say it. So basically now, if we have 10 users, right, and they're key, because we cannot have more than true or false. So imagine that 5 of them have true, 5 of them have false as their key. Anytime I bring in true to return the first user that has true. So you will never be able to get all the values you get, except you loop true. Sorry, you'll never be able to get a value using a key, except you use true. Because you always be getting the first person that has that thing. You'll never be able to get like the second user that has a true equals to something. You get. So that's why to me this doesn't make much sense, but yeah, it works like this. I've never even seen where they use it like this. It's not intuitive. But yeah, that's that. You shouldn't, it doesn't make sense, but they allow it. So you might have a use case, who knows? I'm just speaking from like I might even go back and find out that this has a real use case, but that's that on this. So does anyone have any question before we go ahead? And tomorrow we'll have a more structured class. Sorry for the whole back and forth, but yeah, we'll have a more structured class. But yeah, does anyone have any question about mapping before we go ahead? Or you want to say something? So it's not always going to be a question, right? You might want to say something I didn't touch. Is I totally appreciate that. You understand? If I don't say something or there's something you know about mapping that was not mentioned, please go ahead and bless us with your knowledge. I would really appreciate that. So you can go ahead. If there's something I didn't touch or something you feel like is important in mapping, you can unmute yourself. We're all learning.
Mine.
You understand? Yeah, go ahead. Go ahead. Sorry.
So, what exactly is the essence of the mapping in the code? Because we know that it has a key value pair, yes. But what exactly is it doing, the key value pair? What is the exact function of mapping in the whole Solidity coding function?
Okay, so that why, yeah, this also touches on why booleans for keys doesn't make sense, because when you hear key, you're talking about uniqueness. You're talking about something that it's unique to one person, or it's unique to one data set. You get. So imagine now that we had, just like the way it is used in the ERC20 tokens, we want to be able to store every provider or every, but when I say provider or any body or any contract that want to be able to spend our tokens for us. So you know that kind of thing whereby you go to OpenSea, you start a campaign, you start an auction. When the auction finishes, people are buying. You're not there, but they are buying your tokens. Normal. You should be able to be, you should be the only one to send your token to someone else. but you've already given OpenSea the power to spend for you. So when you're not there, they're spending for you. Now, we want to be able to store. Okay, let me go to your ERC20 token, because in NFTs, you can only assign one provider to be able to spend your tokens for you. So let's go to ERC20 token, Uniswap. You understand? You can have your token on Uniswap and still have it on SushiSwap and still have it on different decentralized exchanges on Ethereum. But different, all of them, once you call, because once you call send per se, once you call send, like that swapping we normally do now on Uniswap. If you have done it before, you understand. If you want to go and swap one shit coin like that, one shit coin like that for Ethereum, so you just go and press approve, then you swap. But now I think they are doing the two transactions in one click, and that I think that's better. So now, if you go there now, you do swap, and when you do swap, then automatically, when you do swap, automatically you are approving them, because in as much as you are the one doing the clicking yourself, it's an exchange, so it's their own contract that is doing the manipulation on your token. You understand? In as much as you're the one pressing swap, that's operation. The token contract is being called by Uniswap contract, not you, because of it is not just you calling it. They have to do like decentralized exchanges. They're like some interesting / complex things happening inside Uniswap that will allow them to be able to swap your tokens at their best. You understand? So basically, they should be able to spend for you, but they are the one doing it. So now we want to be able to store every single decentralized exchanges that are allowed to do stuff for us on our contract, on the token contracts in this case. Now we now have, like I said, we have this, which is the mapping of address and the mapping of another address. So now we have my address here. We'll have Uniswap address here. Then we'll have true or false. We have still my address. You get still my address. We have SushiSwap contract, and we have true or false, as the case may be. Now, this is not unique, but this is unique. So we are doing kind of nested. If you want to get the value, instead of just doing something like this, you get, we'll now be doing something like this. Address, also the address. You understand? So we are kind of nesting it down to the lowest value. You understand? So mappings are very important. That's why these doesn't make much sense to me. You understand? But basically, you would have to use, if you want to store, in fact, there is no better way to me, or there are probably better ways, but there's no better way to store unique values rather than using mappings, because the idea is that once you call that person, once you call that unique value, you should be able to get the data. Once you use the key to call the value, you should be able to get the value without doing things like not getting, because for instance, now the way we are using it now, there will never be two users with one as their value, except there's an error in our code. But what we have in mind is that we want to be able to store each user with one ID. So if we call one, we have a new user. We call two, we have a new user. You understand? We call three, we have a new user. We call four, we have a new user. With the idea that you will not come and add one user twice. You understand? There should be a check somewhere here that checks that you don't put in the name is not really existing or something like that. Blah blah blah. But you get my point. You understand? So do you understand, Elizabeth?
Yes, I do. So it's basically to store data of each user that accesses that particular your own address that you placed on all the people you gave permission to be able to manipulate your token on your behalf. So it's like
Yeah.
the backup data. That's what the mapping. Okay. Okay. Thank
Yeah,
you.
in this case, but basically, it's just a way to store unique values. You need a way to store unique data by mapping them to things that should be unique. So in a contract, there should not be two users that have the same address. So the idea is that only one user will have an address, so it's unique. So with that user, we can get other things that attach to that user. So in as much as I use the token example, just to be able to store unique values. So, and also, do you now understand why this doesn't is not intuitive? This using a boolean.
Yeah, I think I do, because saying false, mapping address false, is there's nothing unique about using a Boolean value.
There will be 1,000 users that have true and there will be 1,000 users that have false. So how do you? It always be giving you the first
That
person.
are false.
Yeah. So that makes sense. So let's okay. At this
I'm
point,
sorry, please, I have a question.
okay, go ahead. Go ahead.
This users names, those things after the mapping, like where did you get them from?
Those things after the mapping. Those things sorry, where? Yeah.
Like mapping public users, these names, like balance. Yes, those stuffs before the colon. The
Or
colon, before the colon.
before the colon. This one now, users.
Yes.
Okay. Oh, they are variable names. They are the variable names.
With these balances approved, that the
Yeah. Yes, all of them are variable names. This one.
like did you just form them or like
Yeah, arbitrary. So I just gave them any name.
okay.
So they are variable names, just like these ones. They are set by me. I just anything in my head. And I'm probably bad with names, but yeah, anything I just like test 1, 2, 3, blah blah blah. They are the same thing. Names, just arbitrary names. Anything you have in mind, just use it. But make sure you don't use things like keywords, like things that already existing in solidity, like using public here and while I would be public. That's problem. But so far it's not an inbuilt keyword in solidity, you're fine. Yeah, you want to say something? Oh, sorry, I go ahead. Say something.
That place that you have viewings, can there be int there too?
Yeah, which one here?
Yes.
Sure. They can. They can be. Okay, there's a problem. But yeah, they're telling you that you cannot just convert. You understand? So you get because see here count is set to uint. You understand? And now since we have changed this one to int, they're not telling that you cannot implicitly just convert uint to int, and we understand the reason because of things like overflow, things like the signing, like basically sign on. You cannot just convert sign integer to unsigned integer because if you convert -2 to uint, what will you be getting? If you say you want to be getting 2, then there'll be a case whereby you're having one serious bug like that that's caused by that was. So basically, if I want to make everything work, I'll just come here and change this to uint and let me see another. Okay, and change this to urine. Then we'll be fine. You understand?
Yes.
Cool. So, okay, let me see. Let me talk about more variables. Let me talk about more data types. We've talked about urines. We've talked about mappings. So let me see. Let me talk about string. Um, So, like I said, tomorrow we'll have more structure. I just wanted to know where we are at, but by tomorrow we'll have more structure and we'll follow it. Try to follow it as much as we can. Whilst taking questions, because that's very, very important to me. So, yeah, mappings. Let's talk about strings. So we've not reached function. We're already talking about function. So now I just explore. Explore is interesting. It's fun. Explore. Okay, should I just do this on that? Let me just do it on that. Yeah, strings. So basically in Solidity, a string is a reference type.
Sorry, can I ask one more question
Yeah,
on
yeah,
mapping?
yeah, go ahead.
Wait, is it safe to say like mapping is like relative or dependent on the struct?
Mm, okay, so far the key is unique. In terms of uniqueness, we don't really care about the value. But so far the so far the key is unique. We don't really care about whether the value is unique or not. But in a situation whereby the key is not unique, then the value will save us, just like this place now, just like this place. You understand? So here, since we'll be storing different people, but we only have one address. So assuming this was not a mapping, and this was just say unit, then even if we try to store this user with new values, something that won't happen, like hey, I didn't even say that before, something that will happen is that anytime you try to update, you keep getting that. In fact, you will never have a situation whereby you have, okay, now I see why this is even possible. So this particular mapping, will always have two values, because anytime you want to update this thing, it will just look for the first one, and it's always give you the first one. I don't know if this makes sense. So imagine we have true and we have false, and we want to update a key of true. It will go and get that true. We want to update the one for false, we go and get that false. So for the lifetime of this mapping, you always have two values. Now this makes sense. But that means if you want to only have two values in your mapping, then you should probably use true or false. So going back to what you're saying, if this address is unique, then we don't have to bother about this. But if it's not unique, then we have to depend on this for the uniqueness. That's where this comes in. When we are doing so the exchange or the anybody you are approving to spend the token is unique, then their value. So when this one is not unique, this comes in. But like generally, it doesn't depend on it. If the key is unique, then the value can be anything. So far, anytime we put in that unique key, we are getting the value we need, then we are fine. Does that make sense?
Yeah, it does.
All right, all right, all right. So for strings, okay, Aisha, you can go ahead and speak.
No, you can continue. That was a mistake.
Oh, fine, that's fine. So string. So basically, if you've done other programming languages, then you probably be familiar with the idea of strings. But basically, what they do is they store strings. They store characters under between quotes. So even if you want to store a number, but you put quotes and double quotes at the end and at the beginning and at the end, it's a string. You understand? So anything you want to store, so far there's double quotes in front and at the back, you are storing a string. You know, so if you write the most complex, if you write the most complex, like let's say you want super coder like this, and you come and write a lot of things, you write code that we use and hack, like in fact, you just write a huge amount of code. Then you now come and do it like this, and put it inside here. I'm sorry, that is a string. It's kind of, it's not it's not a code, you understand? It's not a normal code, you understand? So anything in between a string. So in what am I saying? Anything in between double quotes is a string. So we have the string. So yeah, no matter what's inside here, if you have anything you want to put inside here, so far it's in the double in between the double quotes, and it's a string. So let's try to manipulate it a bit. So while manipulating it, we'll talk about some of the things that are unique about strings in Solidity. I'm getting an error. Why? Okay. It's meant to be a semicolon here. Yeah, so something I want to point out is that please always try and experiment these things yourself. Because no matter how, in fact, it's not even possible to say everything you want to say. There are many variables. You might say it's time, you might say it's your brain that is doing it, you might say it's speed, but it's not possible to say everything you want to say. So always go back and try these things out. You understand? It's just like the same idea of all these people that we used to call them my tuner in class. I'll go and be learning the one that they not teach them. It's actually good in real life, to be honest. So far you're doing it for yourself and not to be just for the fun, just for like the fact that I don't know, but sure, you understand what I'm trying to say. Yeah, always go and do your own research on your own, and you will see a lot of things that you had never mentioned. So strings. So let's try to get the length of the string, because as I was using integers, I would have said let's perform operations, but let's just try to work with this, then would see some things that we did not previously. So let's try to get the length of the string, if that's possible. Okay. So no availability modifier. Okay. If I want to return a value, we have to tell the function that I want to return a value. You get. So if you want to return a reference type, I have to use this memory. At the same time, I think they were getting another error, which is really interesting. Okay, apart from that, this is not even what I'm looking for. I want to see what they're saying. Okay. There's one more error. Blah blah blah. Okay. So we've already they're saying identifier already declared. We have this and we have this, but we are trying to call it, not redefine it. So why is it telling us this? Okay. Okay. Now, this is the first thing you find out. Member length not found or not visible after this. So I think I said Solid is very interesting. So in JavaScript, you can try to get the length of a string, right? In Python, if you do learn and you put a string inside to give you that, first of all, they're not telling that this is not possible. So that's the first thing you understand about strings. You can't get the length of a string in Solidity. So there's something else having to do with how it is stored. But if I can't explain that today, I'll explain it tomorrow. But so this is not possible in Solidity. You can't have length. So that's the first thing you should note. You can't have the length. This doesn't work. Let you know that this doesn't work. I'm sorry. Oh, now I see why they were giving us error. This test string is already a variable name, so that's why we're getting the other error. But at the same time, this wouldn't even work. So let me just. So I should by tomorrow I should be able to give you more details on string, but let me just try something else right now. It's a bit unstructured, that's why. Well, I want to say something about how it's stored first. Okay. Now, if you're talking about reference types, the way reference type works in Stability is that if you have value types like numbers, they are actually, if you're trying to call them, when you call them, you're calling that exact value. So in value types now, like numbers, like integers, mappings, and stuff like that, you'd when you're calling them, you're calling the exact value. So there's something called pass by value and pass by reference. So that's the idea behind value types and reference types, because in value types, you're passing them by the value itself. So if you're trying to call it, you're calling the value itself. But in reference type, you're calling the reference. So using that reference, the program is able to find that particular value you're looking for. Understand? The program is able to find that particular value you're looking for. You get, so that's like the main difference. And just looking at the code, you probably not be able to see something like, apart from the fact that we use like memory and core data and stuff like that, there are not a lot that differentiate how they work, but under the hood, there are different um, value types and reference types. Okay. I want to talk about, I want to leave data type for now, but by tomorrow I would prepare a more structured stuff on strings and other data types. But I want to quickly talk about something that is in my notes. Sorry, give me something that's not that complex, but you should just get the idea quickly. So constants and immutable. So now there's these two keywords. So just, I'm sorry, just leave this for now. Tomorrow we'll come back to this. And also our time is very fast spent. So yeah. Let me just comment everything about this one out. Okay, let me do it up because we need to use a constructor. So constant and immutable. So now, sometimes in Solidity, you might want to declare a value that would never change. Okay, go ahead, Emma.
Can you zoom in your screen?
Okay, sorry. I think I mistakenly. It's better now, right? Is it better now?
Yes, it's better now.
All right. So in Solidity, yeah, I would send the code. I'll create a repo and I'll add in these codes there. So every class you can just go to repo. I would have updated it. So I'll create a repo for this class and we'll use it. Any code I use, I would add it to the repo. So yeah, I'll do that. So in Solidity, you might want to. Okay, Elizabeth, please go ahead.
Please, tomorrow you would teach us how you link your GitHub to your remix, please.
My GitHub, did I? I didn't link my GitHub to things.
So how will you create a repo? Are you not linking it?
No. I just take it and go and paste it there.
Okay.
Well, probably what you mean
Okay,
is
okay,
like,
all right.
yeah, just go. And I'm not like linking it, but yeah, there's a
No
way to
problem.
call somewhere here, but we'll get to that. We'll get to that.
Okay.
So, like I was saying, constants, like you want to be able to store values that would never change. It's actually quite easy. I'll send the link. Oh, okay. I think you're talking about importing it, or are you saying, I'm not, okay, Chi. So I'm saying like you would be able to link your GitHub account to Remix. That's what you're saying, or link code. So I would like to learn that
Not
too.
necessarily link. I think she's talking about
Huh?
codes to GitHub from Remix. I think she was talking about pushing the codes to GitHub
Okay,
from
import,
Remix.
right? You're pushing the code to GitHub
No,
on
as in
Remix.
after coding, you push to
Yeah, I
GitHub from yes.
from Remix, right?
Sorry. Yes,
From
yes.
Remix, directly from Remix.
Yeah, yeah,
Okay. I actually don't know how
yeah.
to.
That's what I'm saying.
Yeah, you might like you can send a link. I actually don't know how to.
Okay, I thought that was how you wanted to create the video. That was how I was
Sorry, we
asking.
can't hear you.
Me? You can hear me? Or okay, Chi. Or Elizabeth.
It's okay,
But yeah,
Chi.
okay. You can send the link because actually I could have, but I would like to see how. Yeah,
Okay.
thank you for that.
Okay. I saw a YouTube video that helped me. After coding, I was able to push to GitHub from Remix. So I'll just look for the video and send it
All
after.
right, all right. Thanks. So yeah, the
Yeah,
idea
I
of
actually
content.
watched the video.
Huh?
I actually watched that same video too of a lady who explained, but mine kept saying error 404. So that was why I thought he wanted to do the same thing.
Okay. I've not
Yes,
actually done that.
I saw your message. I saw your message on the Slack channel. I also had the same issue, but how I resolved it was that on Remix they say you should create a private access key that has a gist access on GitHub. But what I did was to create a key that has both gist and repo access on GitHub together, both of them. So when I used that access key, it went through, and I didn't get that error anymore. So I'll just send the video across and you check it out.
Okay, so I have to create both gist and
Yeah, it's
all
just
right, all right.
so yeah. Let me just quickly talk about content and immutable. Then tomorrow start all over from string and try to finish up most of what we have for because I'm trying to finish up what we had for last week, but at the same time I'll talk about what we are having for this week. And yeah, so content and immutable, you want to store a value that would never change throughout the lifetime of the code. So first of all, let's talk about constant. So first of all, I want to say that since I'm the one that wrote the contract now, I want to store my name. Understand? I want to store my name throughout the lifetime of the contract. Understand? So string owner. String owner goes to easy. So now okay. So now if I want to make this a constant, because now this is just a normal value, normal variable, string variable called outside. If I want to make the constant that would never change, I'll just use constants. I think I'll use it after public. Right. Let me take error. Oh. Expected. How am I getting this error? Okay. Let me try something quickly. Same error. I think I'm making a mistake
I
somewhere.
think the issue is I think the issue is I had that issue. So Remix will tell you that sometimes the variable we use is not unique. So I think it's underlining that owner. That's what it's expecting you to change.
Okay. Mm, okay, I don't think that the owner
I
is
mean
not.
constant keyword.
Huh?
I said I mean the constant keyword. Like try small letters.
I don't think so, but let's try it. Oh, let me try something. Wow, but okay, okay, that's new. Because the constant keyword I actually used in when I was using it, it's actually used that way. But yeah, thank you very much for that. So now, how this works is now since this is constant, then throughout the lifetime of this code, we should not be able to change this. We would not be able to change this, right? Now, the only difference between immutable and constant is that using immutable, you would be able to, like, using constant, you must define it like this. Like, if you remove this value now, let's say remove this value now, there's an error, right? Because we need to say uninitialized constant variable. We need to initialize it. We need to give it a value, right? So we need to give it a value. But now using immutable, they can give us the grace to actually define it when we want to use a when we want to define a constructor. So now if I change it to immutable, this is meant to be covered. I think this is new. Okay, what is it giving us? Cannot have a value type. Interesting. Interesting. This first I'm seeing. They say you cannot have a value type. Immutable. Wow. Okay. So let's change this to an address. Sorry, I'll take it back to the normal side. I had to. Can't see now. Abi? So let's change this to an address. Change to an address and let's give this. Let's take an address, and let's take this address and put it here. Let me see what this gives us. So it works. It works, right? But assuming we wanted to get this address when we were actually um deploying the contract. Imagine we wanted to make this owner the deployer. So we now do something like this. Constructor constructor and you want to do owner to wants to sender. So the MSG is an object in Solidity and it has its own values, right? So it has attributes. Sorry to say that's attributes. So sender is one of them. You can have value, which is the amount of token that was sent into the contract. You can have data. Data is the data about what you want to do. It contains the function you want to call, the arguments of the function you want to call, and stuff like that. Well, we're just using sender now. Okay, yeah, now I remember. The mistake is from me. There's this thing whereby anytime I want to define a constant variable and an immutable variable, I like using capital letters like this. So I now brought the capital letter to the constant instead of it. But yeah, thank you, Akinola, once again. Yeah. So now what they're trying to tell you here is that immutable state variable already initialized. So you don't need to do it again because they've already done it. And you know, remember I said you cannot change it. So once you've already done it, you cannot change it. So but what immutable allows you to do is that it allows you, they give you the grace to define that same thing inside the constructor. Now it doesn't throw an error, right? It doesn't throw an error. But assuming this was constant, let me change this to immutable. Sorry, let me change this to let me remove this. Change this to an address. And change this to Bono. I have two errors actually. Because first of all, I did not because what they'll give you the grace to define it in the constructor, but they'll not allow you to go without defining it in the constructor. So you must give it a value. If you don't give it a value statically, you must pass it in when you're deploying it. So let's see the first error. The first error is that uninitialized constant. You understand? In the constant, they will not allow you to just go like that. You must define the value. See. So if I go back now, and define it this way, it works. But if I now come here now and come and if I don't define it, if I don't define the immutable value, I have an error saying construction flow ends without initializing all immutable state variables. So they're telling you that you must, even if they're giving you the grace, so don't just feel like they've left. You must define it. If you don't define it the way I'm defining it, they are giving you the power to do it in a dynamic fashion, which is basically defining it inside the constructor. I know how constructors work. If you've used object-oriented programming languages, a constructor or an initializer, as it's called, is basically that function or that thing you can call once when you are initializing a variable. Sorry, initializing an object. So a contract is Solid is an object-oriented programming language. So a contract is an object, and an object has attributes and methods, or attributes and functions. So now they're trying to tell you that you must always set an immutable value, whether statically or dynamically, inside the constructor. If you decide to come and set this thing inside another function, it will still give you the same error because it wants to see that thing set. They want to make sure that you are creating an instance. Because what we do when we deploy contracts is that we create an instance, just like in Python now, you create an object and you start creating different instances. So in Solidity, when you create instances, that's when you're deploying, you're having different instances of a particular contract. So they are telling you that anytime you want to create this contract and you have an immutable value, make sure you set it inside the constructor. And that's all for today. We're already fast, our time is very fast spent, but I'll still give us 3 minutes. So please ask your questions. And like I said, tomorrow we have more structured class. I would give you more materials on strings and other. I'll try to touch every other data type. Then we'll rush from there. We'll try to finish up. Yeah. So please ask any question or make any comment you want to make. By 7:10, we'll call it a day. Yeah. So go ahead. Okay, for the immutable, the controller can be used. Exactly, yes. For the immutable, they won't give you the grace to do it somewhere else because you already say that it cannot be changed. So if you define it as a function, there's a high probability that you will not set it immediately. So it kind of like if you can't change it and you have not even set it in the first place, then there's a problem. To me, it makes sense that if you say something is cannot be changed, at least set it. So let's know what cannot be changed. Let it not be like it's default that cannot be changed. Do you get? So yeah, you must set it inside the constructor. You can't set it in any other function. So any other question? Or comments? Something you want to share with us? Yeah, I would assume we don't have any other question. And yeah, thank you very much. So by
Sorry.
tomorrow,
Um,
okay, go
can
ahead.
we have the link to the resource that you sent to us?
Yeah, I think I already did that in the chat. Overflow and underflow. I did that. Okay, let me resend it in case you left the call and came back. I think the chat to clear. So let me just send it again. Okay, Elizabeth. Okay. Yeah, I think so first of all, try and watch the video again. I don't know how quick the video is being sent to you guys, but try and watch the video again. And my DM is always open on Slack. You always ask me questions, and yeah, basically just explore. Just explore. I'm actually still exploring. You understand? I've been doing it for a while, but I'm still exploring because when there's some things you learn and you're like, wow, so these things are actually here. So just explore. Try to some of these things that I mentioned. There's this thing about the brain whereby you don't know you know something or until you need to show that you know it. So maybe you've not used View for the longest time, or you've not used Pure for the longest time. I just hit somewhere and it just clicks, it makes sense. So yeah, I know it's a lot, but at the same time, just explore. And when you see all these things later, they will make more sense. But yeah, tomorrow we'll add more structure, so I don't just throw things around. But yeah, yeah, that's that. So thank you very much for coming today, and please take your time and like um yeah this blockchain to the world overflow and underflow solidity. This was the one I just sent now on top of. Okay, let me try again. Let me share it again. Okay, you've seen it. Yeah, so thank you very much. Please always make sure you take your time. And I know we'll have different things doing and stuff like that, but at the same time, just take some time to look at these things yourself and explore, to really change things for you, to really like help you understand these things better. Yeah, and be curious. Be curious. Curious. So yeah, thank you very much. That's all for today. Yeah, good
Thank
night.
you.
Yeah, thank you. Welcome.
Thank you.
So yeah.